quick problem, rotting oranges. So in this problem, you're given a grid, and each cell in the grid can have three values. 0 represents an empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. So when a orange is rotten, what it can do is that every minute it can infect the cell which is adjacent to it, and so that way if a fresh orange is there, it'll become rotten 1 minute later. So here's an example of the problem where the first cell is rotten, and then after the first minute the adjacent ones, they become rotten, and then it continues until all of the oranges in the grid have become rotten. So here we have to return the minimum number of time it takes until all of the oranges in the grid have become rotten. And if it's not possible, so here's a case where since it can affect only in the 4 directions, up, down, left, right, so it cannot move diagonally. So if there's an orange which is free from infection, we need to return -1. So this problem is categorized as a common Amazon coding interview question, and in 2020 this was the third most frequently asked question. So yeah, given this problem, the way we could solve it is we can try traversing the grid. Every time we encounter a rotten orange, we can visit the grid and make sure that all the cells adjacent to it are also marked as rotten. And we keep doing it until we reach a point where it's not possible for any other orange to become rotten. And at that time, we just return how many turns it took to reach that point. So yeah, let's try coding that solution. So first thing, I'll just create a variable to store the result. So we don't know how many turns it takes, so I'll just create an infinite while loop. So for this, I'm going to create two Boolean variables. One is to keep track of every time. So the exit condition for this loop would be if we are traversing all of the cells and we are unable to spread the infection. So it's a case where none of the oranges are infecting other oranges. So that's the time we need to exit the grid and return the result. So I'll just create a Boolean value to keep track of that. So I'll set it to false. And also create another Boolean value, this to see that at the end if any fresh oranges are present or not. So just call it fresh orange. So now I'll just create a for loops to just traverse down all the cells in the grid. So so basically the way we are going to do is we are going to traverse it, and every time we encounter 2, which means there's a rotten orange, we are going to try processing all the adjacent cells. So if whenever we encounter it, first thing we're going to do is we're going to mark it as an empty cell. So we don't want to keep processing the same cell multiple times. So we say grid I, j. I'll just set it to 0. And then what we need to do is just spread infection. We'll just call a helper method. So yeah, let me just create that. So this one takes 3 arguments. One is the grid itself, and one is the row and column. So I'm returning a Boolean value, and the reason is infects. Yeah, okay, that also is fine. So the reason is that every turn we want to make sure that a new orange is getting infected, because if it's not, then we know that's the condition we have to exit the loop. So for that, let me just set it to something got infected, so I'll set it to true. And we just spread the infection. So so the way we are going to do it is, so we have already determined there are 4 directions in which the infection can spread. So we'll just create an integer array to keep track of that. So int So one is -1, 0. So it can be, the row can reduce, the column will be the same. So that's one option. Another option is +1 and 0. Another option is 0, -1. And similarly 0, +1. So these are 4 directions we can traverse, and then I'll just create a boolean. So I'll create a for loop to traverse down the 4 directions. So int row is equal to I. So this way I'm now having the value for the new row and column that we need to spread the infection is. So let's create a for loop. If row, so it should be greater than equal to 0, dot length, and another thing we need to check is if the cell contains a fresh orange. So for that we just say grid. So if all these conditions are satisfied, first thing is we'll just mark the grid as it is now going to get infected. So for that, I'll just set it to a new integer value. I'll just set it to 3, for example. And the reason is we just want to differentiate it. We just want to say that, hey, next cell onwards, this is going to be a new rotten orange and it can continue to spread infection. And I'll just say result equal to true. So this is just to keep track of, did we spread infection at every, at every cell? And we'll use it as a way to determine whether we need to continue or we need to exit the loop. So at the end, we just return the result. So this what's happening here is that every time we spread an infection, actually this infect, probably instead of that, this is a better way to do it. So this way we're just keeping track of what happened and whether a new fresh orange became rotten after this. So we keep doing it until all the way to the end. At the end, we check if something got infected. If infect, we just increment the result. Else, so now I have two options, if there are fresh oranges left or not. So for that, we should probably create another for loop to do essentially the same thing. I'm just going to copy it. So here we're going to check if grid ij equal to 1. So if there's still a fresh orange remaining, we just want to set the boolean value to true. So yeah, this is a case where we just want to return -1 if it's if we find that there's an orange which is unable to become rotten at all. So for that, we'll do this. Also, another thing is that all the cells which are close to infection, we set the value to 3. We need to now set it to 2. So let's do that. So yeah, that's what we are doing here. So if at the end of it, we always spread infection, we keep incrementing the result. Else, we check if the fresh oranges are present. So if fresh and then we break, and then we just say return result. So yeah, doing a recap. So essentially we're using two for loops. The first time we are going to check if there's a rotten orange, and whenever we encounter a rotten orange, we check if any of the neighboring fresh oranges can be infected. So that's what we're doing here. We just check in the 4 directions. We set the value to 3, and there's just a indication that this next minute onwards this will be a rotten orange. So we do that, and at the end, since we have already processed that particular rotten orange, we set it to 0, and then we continue it until we have done the first pass. So for doing the second pass, we create another loops, and in this we're just the values which were set to 3, we set it to true, because now the orange is rotten and is ready to spread infection at other cells. And whenever that happens, we keep incrementing the result count. And if it's a case where at the end we still have one fresh orange left and we are unable to spread infection in any of the other cells, we set the value to -1. So yeah, hopefully that made sense. Let's try running the solution. Oh, maybe the Boolean value is wrong. Okay, I think I just had to set this one here to be this. Okay, so that was one, and line 47. Okay, I can see a spelling mistake here. Alright, let's try running it again. Alright, all the 3 use cases are passed. We'll try submitting it. So yeah, time complexity. So yeah, the time complexity of this solution will be O of n squared, where n is the number of cells which are present in the grid. This is because every time we keep traversing down all the cells in the grid, and if there's a rotten orange, we process it, and next time we do it again, and this continues until we have processed, I think, all the cells in the grid twice. So O of n squared is the worst case complexity. As for space, everything is happening in place. We're not creating any new data structures. So space complexity will be O of 1, so constant time. So yeah, that's the solution.